Do you hear about that object that's hurtling towards Earth at like 130,000 miles per hour? No, that might solve all our problems. Some intergalactic object. What came blazing out of the darkness wasn't supposed to arrive this fast. A comet-like object from beyond our solar system sprang into view, racing through space at unimaginable speed, changing color and behavior as it closed in. It defied every model, every expectation. On the latest Joe Rogan podcast, the question being raised isn't whether it's natural, but what it could be. Because when something accelerates out of nowhere, there are always two possibilities: unknown nature or unknown design. The sudden acceleration. The data first appeared as a small inconsistency in orbital tracking. A fraction of a decimal point separating prediction from observation. Astronomers at multiple observatories noticed it within hours. The interstellar object known as 3I Atlas, once thought to be following a predictable inbound arc, had suddenly deviated. Its velocity had increased, not gradually, but sharply, as if something had given it a push from behind. Acceleration in space isn't unheard of. Comets often speed up as sunlight heats their icy surfaces, releasing jets of gas that act like natural thrusters. But 3I Atlas wasn't close enough to the Sun for that process to explain its sudden burst of motion. The readings showed a leap in speed of nearly 20% within a single observation window without the expected plume of debris or outgassing signature. It was moving faster, cleaner, and more precisely than any natural object in recorded history. Astrophysicists initially attributed the anomaly to instrument error. Yet, when the European Southern Observatory, the James Webb Telescope, and multiple ground arrays confirmed identical readings, the explanation collapsed. The acceleration wasn't an illusion. It was real. The object's trajectory had changed, flattening slightly, as though it had adjusted course intentionally. For researchers accustomed to the slow ballet of celestial motion, this behavior was unnerving. The acceleration pattern matched neither solar gravity nor sublimation thrust. It was uniform across multiple axes, a kind of smooth, controlled motion typically reserved for engineered propulsion. News of the anomaly spread quickly. Within hours, science communicators, YouTube theorists, and podcast hosts were dissecting the data. The words non-gravitational acceleration appeared in official documents, the same phrase once used for Oumuamua, the first interstellar object to defy conventional physics. 3I Atlas wasn't just moving, it was choosing to move. And that single observation marked the beginning of one of the most unsettling debates in modern astronomy, the debate over natural versus artificial. The acceleration of 3 Atlas ignited a scientific argument that spread far beyond observatories and academic journals. On one side were the traditionalists, astrophysicists convinced that every anomaly could be explained through physics, chemistry, or coincidence. On the other were the skeptics of skepticism, scientists like Harvard's Avi Loeb, who saw in this motion something deliberate, a controlled maneuver impossible to reconcile with the natural behavior of a comet. The official reports emphasized restraint. They described the object's sudden velocity increase as non-gravitational acceleration likely associated with volatile activity. Yet no trace of sublimated gas or dust tails appeared in any of the infrared imagery. Its surface temperature remained low, far below the threshold for water, carbon dioxide, or even ammonia ice to vaporize. The object was cold, inert, and somehow still accelerating. This contradiction became the focal point of late-night science podcasts and long-form discussions. The Joe Rogan Experience dedicated an entire segment to the phenomenon, highlighting how 3I Atlas's behavior mirrored that of Oumuamua, the cigar-shaped object that passed through the solar system years earlier. In both cases, the same unexplained energy signature appeared: movement without propulsion, acceleration without fuel, direction without core. Conservative astronomers called it radiation pressure sunlight gently nudging an extremely light, thin structure. Loeb countered that such a model required 3I Atlas to be almost weightless, more like a sheet than a rock, an interstellar sail designed to harvest starlight. The idea seemed absurd until the data fit perfectly. As the debate grew, something deeper began to unsettle the scientific community. The pattern of acceleration wasn't random. It followed discrete intervals, increasing and then stabilizing in repeating 9-hour phases. The object behaved less like a drifting relic and more like a machine responding to commands. To the public, it became another curiosity in a universe of wonders. To astronomers, it was a quiet existential crisis, proof that the line between natural and artificial had blurred, and that perhaps the cosmos was no longer silent. The pattern behind the motion. When astronomers overlaid weeks of data, the behavior of 3I Atlas revealed a structure far too organized to be random. The acceleration was not a single burst followed by steady drift. It repeated in intervals. Every 9 hours, the object's velocity increased fractionally, plateaued, then reset. Each pulse of movement followed a symmetrical curve identical in duration and amplitude. Natural objects never move this way. Solar radiation pressure acts continuously, not rhythmically. Outgassing, the process by which frozen volatiles sublimate and push a comet forward, produces chaotic spurts, inconsistent in both direction and force. But 3I Atlas moved as though driven by an internal timer, its trajectory altering with the precision of a guidance system. The data spread through research institutions quietly at first. Modeling teams from NASA's Jet Propulsion Laboratory and the European Space Agency began simulating the acceleration in spacecraft propulsion software. When fed into those frameworks, the pattern matched nearly perfectly with low-frequency plasma discharge, a type of propulsion system capable of generating tiny but continuous thrust over long durations. Further analysis showed another oddity. The orientation of the object's rotation shifted ever so slightly during each acceleration pulse, correcting itself with uncanny precision. The movement resembled course stabilization, the kind of automatic adjustment used in spacecraft to maintain trajectory alignment. Astrophysicists, reluctant to embrace speculative conclusions, called the phenomenon dynamic equilibrium adjustment. Others saw it as a form of intentional control, a sign that the object was responding to gravitational influences in real time. Even the raw optical data carried subtle anomalies. The brightness of 3 Atlas increased slightly before every acceleration phase, then dimmed immediately afterward, as though heat was being generated and then radiated away. To some, it suggested chemical processes or magnetic induction. To others, it was evidence of an internal system managing its own energy. By late autumn, observatories worldwide had confirmed the pattern. Whatever 3I Atlas was, it was not a passive traveler. Its acceleration and rotation had become synchronized in a way that implied structure, not chaos, but design. The spectral mystery. While the acceleration of 3I Atlas drew the world's attention, it was the object's spectral signature that caused genuine alarm among astronomers. Using the James Webb Space Telescope and several ground-based infrared arrays, scientists began scanning its surface composition, expecting the standard cometary elements, frozen water, carbon monoxide, and traces of silicate dust. What they found instead did not fit any known profile. The first anomaly was metallic reflectivity across multiple wavelengths. 3 Atlas exhibited a mirror-like return pattern, suggesting that large portions of its surface were composed of refined metals or high-albedo composites. That level of uniform reflectance is impossible for a natural comet, whose surface should be darkened by organic carbon and cosmic dust. The brightness remained stable over time, indicating no tumbling debris or rotating irregularities, only a smooth, consistent texture. Next came the thermal paradox. Despite its proximity to sunlight, the object's temperature did not rise proportionally. Instead, its heat output fluctuated independently of its solar exposure, rising sharply during each acceleration pulse and cooling just as quickly afterward. The infrared charts displayed spikes resembling energy discharges, controlled bursts of heat emission unlinked to sunlight or sublimation. Even stranger were the traces of nickel vapor and carbon dioxide surrounding the object. Those elements do not coexist naturally at the observed ratios. Nickel requires thousands of degrees to vaporize, while co-sublimates at extremely low temperatures. The combination implied alternating cycles of intense heat and near-cryogenic cold, impossible for a static body. When Webb's spectroscopy team compared the readings to known propulsion exhaust signatures, they noticed disturbing similarities. Nickel vapors are a byproduct of plasma thruster alloys used in experimental spacecraft engines. The faint co-presence could indicate a cooling or exhaust system. The data pointed toward technology, or at least something behaving as if it were technological. No official statement acknowledged this interpretation, but internal documents began classifying the object's spectral data as non-standard. Observatories tightened their data channels. Raw images were removed from public archives without explanation. Whatever was on or within 3I Atlas, it wasn't reacting passively to its environment. It was emitting, stabilizing, and possibly managing its own temperature. And as it moved farther into the inner solar system, that control seemed to be intensifying.